Assalamualaikum warahmatullahi wabarakatuh. We are from Group AB, and today we will explain about divergence theorem. So this is our group member, and my name is Risa, and I would like to present introduction to divergence theorem. So the introduction of divergence theorem. What is divergence theorem? Divergence theorem is also known as Gauss theorem. So, this divergence theorem states that the net flow flux of the vector field through the closed surface is equal to the volume integral of the divergence of that field within the enclosed volume. So, this is the formula for divergence theorem. As we can see here, the flux of a vector field through a closed surface like this F is going through the closed surface S is going to be equal to the integral of the divergence over the enclosed volume. So this is the first part of the divergence theorem, the left-hand side. The left-hand side is the surface integral. F is the vector field that fluxing through S, which means that whatever that is going through the surface. And N is the normal vector of the surface. On the right-hand side of the divergence theorem is a volume integral. This is volume integral del dot product with the vector field. There is this version, we need to remember this. And the dot product between this value will be a scalar number, which means that it will be a whole number. It will not be in the vector form. So this is what it means by the integral of divergence over the entire enclosed volume. So divergence theorem gives us equivalent ways of computing flux through some volume. The theorem allows us to relate the behavior of the vector field inside the volume to its behavior on the surface bounding that volume. It provides a way to switch between a volume integral and a surface integral. So it means that if we have a vector field go through the volume, the divergence theorem allows us to compute how much of that material is fluxing through or go through the closed surface, or the rate of change of the material in the volume. In summary, the divergence theorem is a powerful tool that helps relate volume integrals to surface integrals, providing a convenient way to switch between the two and potentially simplify calculation involving vector field and their behavior within a region.
Okay, thank you, Fisa. My name is Muhammad Azraizat bin Nizar. My metric number is B0122103008. Okay, I will present the example 1. Okay, for the first question is evaluate the electromagnetic flux of the vector field. The function is x, 3y cubed and 7z square on the box defined by the limit for x is -2, upper limit is 3, limit for the y -1 and upper limit is 1, and for the z lower limit is 0 and upper limit is 5. Okay, we use this formula to calculate this question. Okay, first step, we sketch the xy plane. Okay, we plot the limit x -2 and 3 and limit y -1 and 1. Okay, we can see from the top view this object. Okay, and then zy plane, we apply limit y -1 and 1 and limit z 0 to 5. Okay, this object we can see from the side view. Okay, for the next we sketch the 3D sketch x y z plane. We get the box. Okay, and then we apply the divergence formula. Okay, first we differentiate the x, we get 1. Then we differentiate the y, we get the 9y square. From 3y cube, we get the 9y square. And then we differentiate z, we get 14z. Okay, from the equation, we integrate dz, dy, dx. Okay, this for limit for dz 0 and upper limit is 5. This limit for dy -1 and 1 and dx -2 and 3. Okay, first step, we integrate the dz. and we get the equation z plus 9y square z plus 7z square, and we apply the limit z 0 and 5 to z. So we get the answer is 5 plus 45y square plus 175 dy dx. Okay, next step, we integrate we integrate dy, and we get equation 5y plus 15y cubed plus 175y, and then we apply the limit y, uh, then we get the answer is 370 dx. Okay, for the last step, we integrate dx, and we get 390x, and we apply the limit x, and last we get the answer is 1950.
Okay, now we move to example 2. The question is, let us be the surface of cylindrical solid D, whose boundary is x squared plus y squared equal to 4, where z is equal to 0 and z equal to 1. And the vector field is x cubed, y cubed, and z squared. So we need to evaluate surface integral. The first thing first, we need to sketch the 2D sketch. So we sketch the xy plane, where the x squared plus y squared is equal to r squared. So x squared plus y squared equal to 4, and we get r equal to 2. So now we actually can determine the limitation of r, where r from 0 to 2, and for the theta, we know that from 0 to 2 pi. So now we move to 3D plane, sketch of 3D plane. So we know that this is the solid cylindrical, so where the z is from 0 to 1. So this is how the solid will look like. So now we already have the all of three limitation for r, theta, and z. So we use dv is equal to dz r dr d theta. So now we move to the equation. Okay, we know that the flood of vector fields f through a closed surface is equal to the integral of the divergence over the entire enclosed volume. So we can get the divergence from this equation, d dx at cube, d dy y cube, and d dz z squared. So we differentiate to get this one, 3x squared, 3y squared, and 2z. So just now we already has the limitation of dz, dr, and d theta. So this is the divergence. And we know that x squared plus y squared is equal to r squared. So we can express x squared plus y squared into r squared. So r cubed, we get this one from r squared multiplied with r. So we get 3r cubed plus 2rz dz dr d theta. And this is the limitation for d theta, dr, and dz. So now we integrate for dz first. So we integrate z, 3r, we get 3r cubed z plus rz squared from 0 to 1, limit from 0 to 1, dr d theta. So after we put the 1 and 0 into the equation, we get 3r cubed plus r dr d theta. And now we integrate for dr, where we get the equation 3 over 4 r power of 4 plus r squared over 2, and limitation of 0 to 2 d theta. So now we get this 14. We get 14. And now we integrate for d theta 0 to 2 pi, and we get 14 theta, and we insert the 2 pi into theta, and we get 28 pi. And this is the final answer for this equation, for this question.
Okay, this is example 1. For example 1, we prove the calculation using MATLAB. So we define the limits of the box, and then define the divergence of function f, and then perform the triple integral over the volume of the box. So the result is 1915 This has proven that our calculation is correct. For example 2, we use the GeoGebra to prove the limit. So we use the z-axis right here, which is 1 to 0, and then the dr limit is the radius, and then the theta is 2 pi because it is a circle. So for application of divergence theorem in electromagnetism, there are two types of application of divergence theorem in electromagnetism. One is to calculate electric charge, and one is to analyze the current flow. So for electric charge, the divergence theorem helps determine the electric charge enclosed by the surface, useful for understanding charge distribution in circuits and battery. And for analyzing current flow, in conductor, divergence theorem of the current density vector is 0. The divergence theorem can be used to verify this property and ensure current conversation in electrical circuits. So, the expression of divergence theorem in electromagnetism. We use the formula to calculate the electric charge for this expression. So, as you can see, this is the basic formula for divergence theorem. And then we apply Gauss law for divergence of E. This is the formula of to calculate the electric charge. And then we need to substitute the formula of Gauss law, the formula of electrical charge into the divergence theorem formula. And then we rewrite the volume integral as the total enclosed charge. Okay, I think that's all from us. Thank you.